Hey, what's up, guys? Chung here again. So this time, I want to talk about this LeetCode problem, 1197, minimum knight moves. Okay, so all right, so let's take a look. So basically, you're given like a knight in a chess game on the chessboard. The starting point is 0, 0, and the chessboard is infinite. And then you have a start. You always start from 0, 0, and then you're given like a target position with x and y here, and you need to find out what's the minimum steps you need to make in order for this knight to jump into the target position. Right? For example, this one, the target is 2 and 1, uh which is this position, right? So and you only need one jump, right, from here to here. And the 5, 5, you need like four jumps from the starting point to that location, right? So and you know, every time you guys see like a minimum numbers, minimum steps, you know, on this like a kind of you have like a different ways of doing this, right? So it's kind of like a graph, right? If you think this is like a graph, you know, every time you got a eight from one positions you have like eight different choices, right? Basically, it means that from one node you have like eight edges, right? And then from there you have another eight, right? And for this kind of problem, every time we ask you to get some minimum numbers, and we know we need a breadth first search, right? Okay, cool. So for the breadth first search, let's take a look. And okay, so the first thing comes to our mind should be the breadth first search, and uh, so let's see. But there is some improvements we can make, right? So because if you think about this, like you know, the target it could be like it could be on the x and y. It could be a negative or positive number, right? But actually, it doesn't really matter, right? Because it's a it's a symmetric like chessboard, right? So no matter if this thing is the target value is somewhere on the uh top right corner or on the top left corner or there here or here, it doesn't really matter. We can always we can always make this we can always change this like target to here, right? The reason of doing that is in that case we can assuming all we need to do is jump on the up and the right side, so we don't have to worry about all those kind of directions, right? Because if we are if we only limit in this case, so basically we're limiting our options on each node to one fourth, right? Instead of we'll try all eight directions, but now we only need to try one fourth of them, right? Okay, so let's try to write these things. So and so first we're gonna define like eight directions. The reason we still need to define eight directions is that on this like on this area, right? In this area, we can uh, it's possible we need to jump on eight different directions, right? But this is our boundaries basically, somewhere here, right? But within here, we still uh, need to should be able to jump in all eight directions, right? But this is the boundaries. We don't want to jump to this side, outside of the boundary. So that's why we still need to define all 8 directions. So direction is gonna be -2, right? 1. You know what? I'm gonna just copy this thing here. So I have a, and then what? And then we have a queue, right? Queue equals to what? The queue is the collections, right? Dot DQ, since we're using a queue to implement the breadth first search, right? Starting point is always 0, 0, right? And then we have a scene dot set, okay? Set gonna be some regular normal implementation of the graph breadth first search, right? 0, 0, okay. Oops, sorry. And now, like I said, we always convert these things to the to the positive numbers of it, right? Then while, okay, of course, there's like steps, right? Steps equals 0. While q, right? While q, and we do a for loop, range length q, right? And then stat in the end, we simply just do a steps +1, okay? And here, current x, current y, right? Goes to a q pop left, right? Pop left, and then we do what? We do a check. Basically, since there's no boundaries of this chessboard, so we there's no so we don't check the normal boundaries, but instead we will check the other kind of boundaries. So first, let's check if this coordinate we have seen this coordinate before, right? If not seen, right? And what? And the so the most, as you guys can see here on the left axis here, right? The Since we're only caring about this part, right? So the leftmost positions this knight can go is here. It's here, right? Because from here they can still jump back to here, right? If it goes beyond this position, let's say if it's somewhere here, then there's no point of doing that because it's going too far off the boundaries. There's no way on the next move this knight can jump back to this boundary. That's why we're using a -2, to check the we use a -2 and this x to limit the boundaries, right? Same thing. For example, the x is here. Let's say here is x, right? And from x to +2, this boundaries, that's the x basically. From -2 to x +2, that's our boundaries. Because anything that's outside of here is doing too much. We don't care, right? So that's why we need to do the boundary check. Here is going to be a -2. Uh, sorry, here. 4 directions in directions here. So because we need to try all the 8 directions here. So it's going to be new x, right? And new y equals to current y plus d1, right? And then we have this new coordinates, and we check for each of the new coordinates. We check if this thing is inside our newly defined boundaries here, right? x, x, and same thing for the y here, right? Still minus 2. Let's do a new y, right? Okay. Then only only it's in the boundaries and it has not been seen before. Then we append this new coordinates to the queue. New y, right? And don't forget to add this new coordinate to our scene set here, right? So that's the implementations for the for the banner search. Sorry, what am I saying? For the breadth first search. And now let's just add our final check here, right? If current x equals to x and current y equals to y, then we find our result. We simply return steps here, right? Uh, yeah, I think that's all for this implementation here. Let's try to run it. Not in C append typo. Hmm. Hmm. Let me see. Not in C and oh, sorry. Yeah, like I said, has to be the boundary has to be a 2, right? So we allow this thing to jump 2 more far to the right, so it can jump back. Same thing for the y here. Yeah, so it passed. All right. So uh, so standard. I think it's the takeaway point from here is that since it asks us to get the minimum number of steps, it's so we should try to use breadth first search since this is like kind of a graph kind of problem. And other than that, for the graph search, right, we are trying to limit the boundaries of our search area, right? So basically the boundaries will be from 0, 0 to this x, and we are allowing a -2 and +2 as the offset, right? You can make it bigger, but I think 2 is enough, right? 4 will be safe, but 2 will be enough in this case. You can prove that. Yeah, 4 also works, but it takes a little bit longer time. And then, yeah, just regular breadth first search. In the end, we just return the steps here. Oh, and one more thing here. So we're converting this thing to the always to the limit to the top right corner, right? So that we can only focus on checking the boundaries for this area and not worry about all the others because all the other positions they're all symmetric, so we can always map to the uh, top right corner. Okay, cool guys. I think that's it for this problem. Yeah, thank you so much for watching the videos. See you guys soon. Bye bye.